check it out. Materials that we need for our first experiments are a beaker, a Coca-Cola, and a milk.
Okay, so right now we are going to pour the Coca-Cola into the beaker. After that, followed by the milk. You can clearly see that the color changed to the light brown color. So the phosphoric acid contained in the Coca-Cola now mixed with the milk. But why?
This is because that the phosphoric acid molecules attach to the milk, giving them more density and separate out, while the remaining liquid that mix up the milk and Coca-Cola now being lighter floats on top.
Therefore, the solid matter is basically milk that has been curdled by the addition of the more acidic soda.
It's out for our second experiment.
Okay, so right now we need some salt and also Coca-Cola.
Prepare some salt and pour immediately into the Coca-Cola after you open the Coca-Cola.
Remember, do not shake the bottle before you carry out this experiment. So right now we are going to open the bottle. Okay, so pour the salt immediately into the bottle.
That the soda tends to shoot up and out like a fountain.
Maybe you will ask, how does it happen?
This occurrence shows that when the salt is added into the Coke, it changes the balance of chemistry and forces the release of carbon dioxide bubbles.
This occurs because the salt overpowers the carbon dioxide and replaces it in the soda. The carbon dioxide then has nowhere else to go but out, causes the explosive sensation. Do you guys get it?
Experiment in this video.
In this video, this is about the relationship between the air pressure and the changes of gas volume in the soda.
The only material that we need in this experiment is Coca-Cola. As we all know that if I shake the Coca-Cola, it will explode like a fountain. You guys saw it, it explodes.
But I'm going to do something different with Tung. I can pretty sure to tell you guys that even I shake my bottle, it won't explode like Tung did. I will then tap lightly around the bottle and then open. See, it does not explode.
This is because that when the can is shaken, the carbonate drink in it will produce carbon dioxide and will diffuse in the drink in the form of bubbles. Normally, when we open the can, the bubbles in the drink will spill out from the can. But if we tap the can lightly around the can, the bubbles will break. So, when the can is open, the drink will not spill out.
Oh, such a good explanation. Now, let us start our last experiment.
Yeah! Well, we do need a plastic spoon, a Red Bull, a milk, a beaker, a Coca-Cola, and a cloth.
So first, we will pour the Coke into the beaker. Just pour in all. And then add some milk. So you can see that it goes a light brown color and it almost looks like it is starting going to curdle.
Next, I am going to pour in some Red Bull to see what will happen. You can see that straight away it looks like everything is separating and you get this red froth starting to rise to the top.
I'm putting a cloth in short so I can speed up the video so we can see what happened over the time.
After about a minute, you can see one brown layer of the froth has risen to the top and another layer is starting to fall to the bottom.
So if we leave it to settle, after about 10 minutes, we get these three distinct layers.
Heavier light brown gum at the bottom, yellowish brown fluid in the middle, and this horrible foam layer on the top.
So if I try and pick up some with a plastic spoon, you can see what it is like. and this layer at the bottom kind of just disperses as you try to pick it up.
Let me explain to you about this experiment. The protein in the milk starts to denature because the coke is quite acidic. The red brew just for speeding up the process. The gunk that you see on top and on the bottom of the glass is just denatured protein. Get it?
That's all from us. Thank you for your watching.
Bye-bye!